Okay, hello, it's FY here. So today we're going to look at the improper integrations of unbounded interval. There are two types of these improper interval. Okay, and in this video we'll focus on type number 1. Okay, let's look at the definition directly. So when you are seeing an infinity in an integrations, okay. So what you have to do is, okay, if you look at this definition, it basically asks you to substitute this infinity with a t. So that's why we have a t here. The next thing that you have to do is, okay, write a limit in front of the symbol of integration. Okay. Perhaps you will come across the case that you will have a negative infinity down here. Okay. We're going to do the same thing. So what you have to do is try to substitute this negative infinity with a t. So therefore you have a t here. And put a limit where t approaches to negative infinity in front of the symbol of integration. Okay. And if you look at here, okay, I write here that whenever you are able to find the limit, and the limit exists as a finite number, means that you have some answer. You have a number which is number 2, number -3, some number which says that the limit actually exists, okay, and we call it as convergent. Okay, but if you find out the answer, is actually in terms of infinity, which is not a finite number, then we say that the limit does not exist, or in the term we say that it's divergence, right? Okay, so let's just look at the example directly. First, through the example, you understand more on the definitions. Okay, so let's just look at the example. Okay, if we look at this example, same thing. We have here an infinity here. So what you have to do is, first of all, add a limit in front of the integration, the symbol of integration. So put it as t and approach to this infinity. Okay, and write back the symbol of infinity. Write back the symbol of integrations and change this one to t. Okay, and the rest we're going to write it back. I use a highlighter mirror so you can see that. Okay, so I change the infinity to t and I put a limit in front of the integration. Okay, so now what's the next thing that we should do? Okay, the next thing is you have to rewrite back the limit. Okay, and we're going to treat this as a normal integration. Okay, so 1 over x. Okay, if you integrate, this actually give you ln x, right? Okay, so this basically give you ln x. Okay, and we have a t here, t, and 1 here. Okay, and the next thing we're going to do is, again, we're going to copy back the limit. Okay, and do the substitution. Okay, so we have ln. Okay, so this is t here. Okay, and substitute here, so we have minus ln 1. So what we have here is basically ln 1 is actually equal to 0. So we have ln t minus 0. So my ln t minus 0 is still ln t. And now, okay, let's substitute back to the here. Okay, so we have ln t, the t is infinity, and sub we have a result of ln infinity. Ln infinity is actually equal to infinity. Okay, so ln infinity is equal to infinity. Ln infinity is equal to infinity. Okay, because the answer itself is an infinity we say that the limit does not exist. The limit does not exist. Does not exist as a finite number, right? Okay, so it does not exist. And then this is a case of we say that it is divergent. So it is divergent. Alright, okay. Let's also get other example. Okay, let me push it aside. Okay, so let's look at the example 2. Okay, so now same thing. Okay, what do you see here is you see an infinity on the integration, the symbol of integrations. Okay, so what you have to do is change this one to t. So we're going to put a limit. So this is a t approach to this infinity, and change this to t. So basically, change this to t, and we put a limit in front of the symbol of integrations. Okay, the next thing, treat it as a normal integration. So when you integrate with respect to x, okay, what is e power minus x, okay, so we have e minus x over minus 1, okay, and put this next to it t2. This is a normal integration. It's very simple, okay, and at the end we have limit, okay, and we have negative 1 over e x, okay, and this t is 2, okay, we're going to do the substitution. So we will have e t minus e power 2, right? Okay, so now okay, so let's just simplify it. So when you simplify it, you will have this one is a plus, okay, and let's just see what happened if we sub the infinity in here. So we have e infinity plus e, okay, so you have e power infinity that is infinity, and you have minus 1 over infinity that is basically equal to 0, and the answer is actually 1 over e squared, right? Okay, 1 over e squared is a finite number. You have a number here, okay? So whenever you are able to find an answer, okay, a finite number answer, this is the limit is exists, and it is convergence. It is convergent. Okay, let's look at the example 3. Okay, so same thing. So you can see that we have an infinity here. So what you have to do is try to write a limit in front of it. Okay, so approaching to this infinity. Okay, so change that infinity to t. So we have x e minus x dx. Okay, so the next thing that you have to do is we try to integrate, but in here we have two parts. Okay, so we're back to our basic of integration. So we'll do that. Okay, so we're gonna analyze it. Okay, so we have LATE. So what do we have up here? First is you have the x algebra. So we're gonna let the x as u, and we have the ex, okay, which is at the back. So we're gonna let the dv as e minus x, so this is equal to differentiate it, so we have du dx, this is going to integrate it, so you have e minus x over minus 1, so it's basically equals to minus e minus x. Okay, so now okay, we're going to use the same concept that we have learned previously. Okay, so the result of integration is basically uv minus v du. So let's do the substitutions. Okay, so what is our u? Our u is x, and our v is minus e minus x. Okay, minus v, the v here is minus e minus x, and du is actually dx. Okay, simplify it. Again, simplify it. So this gave you minus x, e minus x. Okay, so minus minus is actually plus. Okay, so this one is you can integrate it. Okay, let's just integrate it. So if you integrate this, of course, we will have the same thing. We have e minus x over minus 1. Okay, and simplify it one more time. Alright, okay, so basically that is the result of integrations. And don't forget the interval that we have. Okay, this t is 0. Okay, now we're going to do the substitution. So just copy back the limit. Okay, so in here we have the first, that is minus t, e minus t, and change all the x to t, so we have e minus t. Okay, minus the next bracket, that is this one. I push it up a bit. So next we have the 0 here, so we have minus 0 is 0 minus e 0. Okay, so basically we just do the substitution, and let's just simplify it. Don't ever substitute the infinity first. Okay, just leave it that way and simplify this. So basically this is 0, and we have a minus 1 here. There's a minus 1 here. This comes from 0, and it's actually minus 1. So minus minus will give you a positive 1, right? Okay, so let's just deal with this. Okay, so for those involved with the t, so we have to consider to substitute the infinity inside. Okay, but in here we have special case that you need to modify it, which is actually back to our previous chapter. Okay, our previous chapter says that you have to modify it because it's in the form of infinity multiplied with 0. This is the infinity, the form of the negative infinity multiplied with e minus infinity. So it's basically minus infinity with 0. So this is the form that you need to modify. Okay, so try to modify this one just that you can sub the t as infinity successfully, right? Okay, so how to modify that is very simple. That is back to our previous chapter. Okay, you're going to drag this one down. Okay, so just modify this. So we have the minus t over e power t, alright? Okay, and this is the same thing. This is the same thing. We're going to write it back. Okay, so we have, I'll ignore the bracket here. Just have to here. Alright, okay, and I have the limit. I give it to the exponent. So we have e minus t plus 1. Okay, and okay, what happens if you do this way? So basically this is actually in the form of the negative infinity over e infinity. This is actually infinity over infinity. That is the term that you can apply orbital. Okay, so you can apply orbital here. Okay, so you apply the orbital to this item on it. So when you apply orbital, so on the top we will have -1, in the bottom we will have ET on the right. Okay, so for this, we still have the 1 over ET, right? Okay, and it is +1. Okay, so this part, only this part, we apply the orbital. Okay, so let us see what happens if we do the substitution in here. Okay, so when you do the substitution in here, so you will have 1 over E infinity minus 1 over E infinity plus 1. So basically this is minus 0 plus 1. As a result, we will have 1. Right? So this is the answer for the example 3.